Go. One of us is going. Alright guys, welcome back. This is part 3. This is part 3 of our lesson over the unit circle.
It's a trilogy.
It's a trilogy. Stay tuned for the prequel. Alright, so guys, if you remember yesterday, we were finishing up looking at some of these points on our unit circle. If you remember, the unit circle has a radius of length 1 and is created by having the vertex at the origin and drawing a line over a radius over to that first point, dropping a vertical leg. And if you remember, that first point that was created was a 30-degree angle. Now, if we continue the process of moving this radius up to here, that's a 45-degree angle that's created, 60, and of course 90, and so forth and so on. So what I want to do is just remind you of this. Now let's talk about every point along this unit circle that has exact values is in terms of ordered pairs. So I'm going to take this off. I'm going to try and write a little bit bigger, but this is our 30-degree point. This is our 45-degree point. This is our 60-degree point. And of course, that's opening up that terminal side. This is our 90-degree point. That 90 looks terrible. I'm going to fix that right quick. 90 degree. And then we got 120. And of course, 135. 150. 180 degrees. Then we have 210. We have 225. We have 240. We're going to have 270 degrees, 300 degrees, 315 degrees, 330 degrees. Now, of course, here we started at 0, but this is also 360 degrees when we wrap all the way around the circle. Now, Mr. Simmons is going to tell us about the radian measures around here by converting each one using the conversion formula. Take it away.
Really? That would take such a long time. Instead of multiplying each one of these by pi over 180 degrees, I'm just going to simply count as I go around the unit circle. Now I know 30 degrees, if I did that conversion, I would have, let's do a different color here.
Absolutely.
I would have pi over 6.
Pi over 6?
1/6 pi. So 30 degrees is 1/6 pi. So I'm going to ignore my multiples of 45 degrees. And right now I'm only going to concentrate on 30 multiples of 30 degrees. So I've got 1/6 pi, 30 more, puts me at 60. So that's 2/6 pi. And 2 pi over 6 will reduce to pi over 3. And that's the form we want to use for 60 degrees, pi over 3. 1/6, 2/6, 3/6, 3 pi over 6, and that reduces to 1/2, pi over 2. So I'm at 3/6, 4/6, 4 pi over 6, and that reduces to 2 pi over 3. 4/6, that's a 45. 4/6, 5/6, 5 is prime, doesn't reduce. Since 5 is not a factor of 6, 5 pi over 6. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 6 over 6 is just 1. So that just leaves me, squeeze that in there. Well, that was terrible.
Kind of hard to squeeze in there.
That gives us just pi.
Just pi.
All right, 6/6, 7/6, 7 pi over 6. 6/6, 7/6, 8/6, and 8 pi over 6 will reduce to 4 pi over 6. I'm sorry, 4 pi over 3. 8/6, 9/6, And 9 pi over 6 will reduce to 3 pi over 2. I don't know about you, my students have become experts at math inner.
Oh yes, definitely math inner.
9 pi over 6, 10 pi over 6, and I'm just counting around. Anyone can count by sixths. And 10 pi over 6 reduces to 5 pi over 3. 9 pi over 6, 10 pi over 6, 11 pi over 6, that will reduce. And one more gives us 12 pi over 6. And 6 will go into 12 exactly 2 times, giving us 2 pi, or for rotation.
That's correct. Very good, Mr. Simmons.
And the 45 degrees, if this is pi over 2 at 90, 45 is half of 90, and a half of a half
Is a
is a
fourth.
fourth. So I've got pi over 4 for 45. 2 pi over 4. 2 over 4 reduces to 1/2, pi over 2. 1/4, 2/4, 3/4, 3 pi over 4. And one more gives me 4/4. 4 over 4 reduces to 1 pi. 3/4, 4/4, 5/4. 5/4, 6/4 reduces to 3/2. 7/4 won't reduce. And 8/4. 8 divided by 4 is 2. So you don't have to convert all of these degrees to radians, and you don't have to sit there. It doesn't take much effort to generate the unit circle, just counting around by 6 and 4ths.
That's right. Do you want to give them a little trick maybe to help them remember other than counting, or you want to just leave it counting?
How's that?
All right, this is the way sometimes I can remember it, guys. It helps me. But you got to remember the first quadrant. The first quadrant angles are very important. So you got pi over 6, pi over 4, pi over 3, right? Now,
6, 4, 3.
there you go, 6, 4, 3. That's right, 6, 4, 3, 2, I guess, if you go all the way up to the quadrantal of 9 degrees. All right, so we got pi over 6, pi over 4, pi over 3, pi over 2. Now, if you'll notice, it starts back around 3, 4, 6. So 6, 4, 3, 3, 4, 6. Now let's look at the numerator.
Like a 6,
Oh, that's perfect.
4,
3.
3, 2.
There you go. That's perfect. So how do we know, though, the numerator that is 2 over the 3, 3 over the 4, and 5 over the 6? The way I remember it, it is 1 less than the denominator. Works out.
Nice.
And then we come here, and we have 7 pi over 6, 5 pi over 4. So again, with the we have the 6, 4, 3.
There you go.
There
That's
you
one
go.
generate we're looking at that.
There you go. 6, 4, 3. Again, just like we had 3, 4, 6, have 6, 4, 3. And so I remember that in the third quadrant, I'm 1 more than the denominator. So 7 pi over 6, 5 pi over 4, and 4 pi over 3. So the numerator is 1 more than the denominator. Then when I get here, this, what I figured out, not here, but here, at this point, what I figured out is my numerator is 1 less than twice the denominator. So if I double the denominator 3, I get 6. 1 less than 6 is 5. If I double 4, I get 8. 1 less than 8 is 7. If I double 6, I get 12. 1 less than 12 is 11. So these you need to know without a shadow of a doubt. These are the most important ones anyway. But
Correct.
then if you go across pi over 6, pi over 6, pi over 6, pi over 6, 4, 4, 4, 4. But you'll know the numerators then become the more important ones. So straight across, pi over 6, but it's 5 pi over 6. Straight down, 7 pi over 6, and straight back across, 11 pi over 6. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. 1 pi over 3, 2 pi over 3, 5 pi over 3, 4 pi over 3, and then 5 pi over 3 is the way I like to remember these.
Nice.
It's just a quick method instead of counting around it, and it depends on what you're doing and how much you're using it. But it's not bad.
I like that.
Now the question, Mr. Simmons, is what are we going to do with this blob of math? What are we going to do with this stuff? What is the whole goal in learning the unit circle?
Well, we're going to get to graphing, and functions, we're not going to cover that. But in terms of unit circles, if you know the unit circle, you immediately know the sine, cosine, tangent, cosecant, secant, and cotangent of all of those common angles.
So now, if we wanted to know the sine of 45 degrees,
Root 2 over 2.
How did you get it that fast, Mr. Sim? Now that's what I'm, 3 snaps, Z formation. That's what I'm talking about. Alright, so if we come back, we said that from yesterday that sine of theta is our y value. Cosine is our x value. The way you can remember this is alphabetically C comes before S, so CS, cosine, sine. So if we look over here to our 45-degree angle right here, or pi over 4, we said sine, the sine is the y value, it's the square root of 2 over 2. Very good. So we know that is the square root of 2 over 2. Well, what about the cosine of, say, 7 pi over 6, Mr. Simmons?
Now, 7 pi over 6, using your trick, it's one more than the denominator. So that's going to put it in the third quadrant. Okay? So,
if we go back, scroll down again.
Right.
Apologize about scrolling, but it's okay. So where's 7 pi over 6?
right here,
210 degrees.
I forgot what you asked for. Sine.
Cosine.
Cosine.
So cosine has to be the x value, which is negative the square root of 3 or root 3 over 2.
3 over 2.
That's right.
Negative 3 over 2.
So negative root 3 over 2. All right. So now you start to see how sine and cosine works. It's either the x value for cosine or the y value for sine, depending on where we are on that unit circle. But Mr. Simmons, what if I asked you a question like tangent? What if I wanted the tangent of, let's start to use more radians.
All right.
What if I wanted the tangent of 2 pi over 3?
Interesting. Now, tangent is the y-coordinate over the x-coordinate.
We've already learned that.
Yeah.
So
And so we're dealing with
is it x over y or y over x?
y over x.
Okay,
Did
I don't
say
remember
x
what.
over y?
I have no idea. If you did.
Y coordinate over x. I was thinking sine over